Algebra Unit 10, Lesson 7, Note 7, Solving Quadratics by Completing the Square. In perfect square trinomials, in which the leading coefficient is 1, there is a relationship between the coefficient of the x term and the constant term. So here we have x plus 5 squared. When we expand it, we get x squared plus 10x equals, or plus 25. The x term, or notice that 10 divided by 2 squared equals 25. To get the constant term, divide the coefficient of the x term by 2 and square the result. Any quadratic expression in the form x squared plus bx can be made into a perfect square by using a method by completing the square. So let's do a few examples. Let's start with A. Solve the following quadratic equations by completing the square. Find the exact roots and round to the nearest tenth if necessary. Okay, so the first thing you need to do is you need to have your constant, or your c term, on one side of the equal sign and everything else on the other. So I'm going to add 15 to bring that over. So this is a little different than how we've solved before. Okay. So what I want to do is I want to take this b term, which is negative 2. Okay, so off to the side, I'm going to take b, which is negative 2, divide it by 2, and then square it. And you're always going to do that. B term, divide by 2, then squared. So negative 2 divided by 2 is negative 1, and negative 1 squared is 1. So what I'm going to do is I'm going to then add 1 to both sides. So I have x squared minus 2x plus 1. And then over here I'm also going to add 1. What you do to one side, you have to do to the other. Well, 15 plus 1 is 16. And what happens here is I wind up with x minus 1 squared. I got that from over here. When I divided negative 2 divided by 2, I got negative 1. That's what goes in here. Okay? If you were to expand this, FOIL it, you would get x squared minus 2x plus 1. From here, solving is quite simple. We're going to square root both sides. I am left with x minus 1 equals, remember, a square root can either be positive or negative, so I have plus or minus 4. I'm going to break this apart into two equations. X minus 1 equals 4, and x minus 1 equals negative 4. Because again, square root of 16 could be positive 4 or negative 4. Add 1, and I get 5. Add 1, and I get negative 3. So the roots of this quadratic are negative 3, 5. Okay, let's try letter B. Again, I want my constant on one side of the equal sign and everything on the other side, which it's already there, so we're good to go. I'm going to take the b term, divide it by 2, and square it. 2 divided by 2 is 1, and when I square that, I get 1. So again, I'm going to add 1 to both sides. (35 plus 1 is 36. This now breaks into x plus 1 squared. Square root, and I get x plus 1 equals positive 6, and I get x plus 1 equals negative 6, because square root of 36 could be both positive and negative 6. Solve both equations. And we get negative 7 and 5 as the roots. Letter D. I need the constant on one side of the equal sign, so I'm going to move it over by adding. X squared plus 8x equals 4. I'll take the b term, which is positive 8, and divide it by 2, and square the result. 8 divided by 2 is 4, and 4 squared is 16. So I'm adding 16 to both sides. Four plus 16 is 20. Over here, again, I'm focusing on this number before it was squared, which is positive 4. So this is x plus 4 squared. Another way to think about it is it's half of the middle term, okay? All right, from here we square root, and we get x plus 4 equals, now the square root of 20 is not a perfect square. So we're actually going to write it as square root of 20, because I don't know what it is yet, and x plus 4 equals the negative square root of 20. Now, here's the tricky part. Square root of 20 we have to try and break down. Is there a perfect square that goes into square root of 20? And there is. 4 is the perfect square. So this can really be square root of 4 times square root of 5. And remember, square root of 4 is 2. So we are left with x plus 4 equals 2 square root of 5. You can do the same thing over here. You do not have to show the work twice, but I will anyway. So x plus 4 equals negative 2 square root of 5. It's the same thing, I just simplified it. Subtract 4 from both sides. I have x equals, I like to put my number first, so negative 4 plus 2 square root of 5. Over here, I'm also going to subtract 4, and I get x equals negative 4 minus 2 square root of 5. So the directions say to find the exact roots and round to the nearest tenth. So this right here, this is an exact root as well as this one. Okay, so basically simplifying the radical will give you an exact root. So my exact roots are x, I'll write it down here, x equals negative 4 plus or minus 2 square root of 5. So I combine them, or you could write them separately like I boxed right above. It also says in the directions to find the to round to the nearest tenth. So now in your calculator, I want you to do negative 4 plus 2 times square root of 5. And when you do that, you get 0.472. It says round to the nearest tenth, so I would say 0.5. Over here again, put in negative 4 minus 2 times square root of 5, and we get negative 8.472, which is negative 8.5 rounded. So our two roots rounded are negative 8.5 comma 0.5, and our two exact roots are negative 4 plus or minus 2 radical 5, or again, you could just leave them as this and box them as two separate roots. There will be times where you do not have a leading coefficient of 1. So here's what we need to do. We need to make it 1. So the first thing I'm going to do, before even rearranging my problem, is I am going to divide by the leading coefficient. So my a squared term, or x squared term, in letter A is 2. So I'm going to divide everything by 2. So I am left with a squared equals negative 6 divided by 2 is negative 3, and 8a divided by 2 is positive 4a. I need to do some rearranging because I need my number by itself, my constant. So I will subtract 4a to bring these over. A squared minus 4a equals negative 3. Now I'm ready to complete the square. Same as the front, take your b term, divide by 2, and square it. Negative 4 divided by 2 is negative 2. Square that, we get positive 4. A squared minus 4a plus 4 equals negative 3 plus 4. Negative 3 plus 4 is 1. Over here, again, focusing on the division, it's minus 2. We have a minus 2 squared. Again, it's just half the b term. Square root. We have a minus 2 equals positive 1. And a minus 2 equals negative 1, because the square root of 1 is plus or minus 1. Solve each equation. And we get our roots as 1, 3. Let's jump to E. My leading coefficient is 3 because it's with my x squared term. So I will divide everything by 3. I get x squared equals negative 4 divided by 3 is not a nice number. So I'm going to leave it as negative 4/3 plus, and again, 8 divided by 3 is also a repeating decimal. So leave it as 8/3 x, or 8x over 3, whichever. I need my x squared, or my x term with my x squared term. So I'm going to subtract 8/3 x from both sides. X squared minus 8/3 x equals negative 4/3. So this gets a little messy. This is why it's nice to have your calculator handy. I'm still taking my b term, which is negative 8/3, and squaring it. Oops, I have to divide that by 2, and then square it. Use your calculator. Negative 8 divided by 3, put that in parentheses, then divide by 2, and when we do that, we get negative 4/3. Square it, we get 16 over 9, and leave these as fractions. So what I'm going to do is add 16/9 to both sides. So x squared minus 8/3 x plus 16 over 9 equals negative 4/3 plus 16 over 9. Use your calculator. Negative 4 divided by 3 plus 16 over 9 equals 4/9. Over here, we have x, and half of negative 8/3, which we've already figured out, is negative 4/3. So it's x minus 4/3 squared equals 4/9. Square root both sides, and we get x minus 4/3 equals the square root of 4/9. You'd basically take the square root of the top and the bottom. Ends up being perfect squares in both the numerator and denominator. So it equals positive 2/3. And x minus 4/3 equals negative 2/3. Solve both equations. We get x equals 2/3 plus 4/3 equals 6/3, which is the same as 2. Over here, when we add 4/3, we still end up with a fraction of 2/3. So your roots are 2/3 and 2. So dealing with fractions isn't that bad so long as you use your calculator along the way. Makes it a little bit more simpler. Okay, let's take a look at letter F. Again, the leading coefficient is not 1, it's 3, so I'm going to divide everything by 3. That's always going to be your first step. So I have x squared plus 4x plus 27 equals 5. Now I need to move this constant to the other side. X squared plus 4x equals negative 22. Take your, that should be an x there. Take your b term, which is positive 4, divided by 2 and square it. 4 divided by 2 is 2. Square it to get 4. So I have x squared plus 4x. I'm going to add that 4 to both sides. Negative 22 plus 4 is negative 18. And over here, I have x plus 2 squared. Square root both sides. I get x plus 2 equals, you should see an issue when you plug this into your calculator. You have a negative under a square root sign, a negative under the radical, which can't happen. So when that happens, and your calculator will give you some sort of error, there are no real roots. And I believe if you're using a TI-84, it'll tell you non-real. And in that case, there are no real roots. What that means, when you have this parabola graphed, let's just say, I don't know where this one is specifically, it has no real roots, which means it never touches the x-axis. There are no x-intercepts. Okay, see if you can complete the rest on your own.